We are going to continue chapter 14 by looking at our probability rules. But before we look at rule number 4, we need to talk about what the term disjoint means. You will also hear mutually exclusive used to also mean disjoint. So the definition of disjoint are two events that have no outcomes in common. So for example, let's say you're rolling a dice. We know the only options for rolling a dice are the numbers 1, 2, 3, 4, 5, and 6. Well, one event might say find the probability of rolling a 2, and the other event might say find the probability of rolling a 5. Those two events don't have any outcomes in common because the first one is only looking for a 2 and the second one is only looking for a 5. So now that we've established what disjoint means, we're going to look at what's called the addition rule. It requires two disjoint events, A and B, and it says the probability that one or the other occurs is the sum of the probabilities of the two events. So simply written, the probability of A or B is equal to the probability of A plus the probability of B. Another form that you will see it written in is this right here. This little U-shaped symbol, this is the symbol for the word or. So if you hear the word or will always mean add. So, that being said, let's look at one more definition. The next definition we have to look at is the definition of what's called independent events. This is slightly different than disjoint. Two events are independent if the outcome of one doesn't affect the outcome of the other. So again, I'm going to go back to rolling a dice. If we are rolling a dice, we know our options are 1 through 6. If you roll a 1 on the first roll, and then you go to roll the die again, that doesn't mean that you can't get a 1 anymore. You can still easily get a 1. Those are referred to as independent events because the first roll doesn't affect your possibilities for the second roll. This leads us to our multiplication rule. The multiplication rule requires two independent events, A and B. And it says the probability that both A and B occur is the product of the probabilities of the two events. So, the probability of A and B is now multiplication. So, and will mean multiply. We also have this little upside down looking U symbol. That's the symbol for and. And then another word that will come up in our problems is the word then. Then is just like the word and. So and or then both mean multiply. So now that we've learned that or means add and then mean multiply, we're going to look at some examples that go with all of these. So suppose you fly from St. Louis to Atlanta every Friday. The airline website says the flight is on time 85% of the time. What is the probability it will be on time 2 weeks in a row? So I'm going to rewrite this using a word that we're more familiar with. If it means that you are on time 2 weeks in a row, it means that you were on time week 1, and it means you were on time week 2. The reason I rewrote it is because it inserts that word and there, and we just learned that and means multiply. Now, one thing that you need to realize about probabilities. We will see a lot of probabilities in the form of percentages, but if it is a percentage, you are never allowed to leave it in percent form. You're required to use decimal form. So as we've learned, you can either move the decimal 2 places to the left, or you can divide by 100, whichever one you feel more comfortable with. But 85% is going to change to 0.85. So what's the probability that you're on time the first week? Well, it's 0.85. What's the probability that you are on time the second week? It's also 0.85. It doesn't change just because it's the next week. And so then you simply type in your calculator 0.85 times 0.85, and your answer is 0.7225. And that's how we leave it. Probabilities are always numbers between 0 and 1, so we leave it in decimal form. Let's look at the next example. In a large introductory statistics lecture hall, the professor reports that 55% of the students enrolled have never taken a calculus course, 32% have taken only one semester of calculus, and the rest have taken 2 or more. So we have 55% who have never taken, and do some color coding here. We have 32% who have taken only one semester, and then we have the rest who have taken 2 or more semesters of calculus. The professor randomly assigns students to groups of 3 to work on a project for the course. What is the probability that the first groupmate you meet has studied? So we have 3 questions to answer here. The first thing we want to find out is what's the probability that the first groupmate you meet has studied 2 or more semesters of calculus? Well, if you notice, that was the one that said the rest. So we know that a perfect percentage is 100. So the first thing we're going to do is we're going to take the 55 and the 32, and we're going to add them up, and that leaves us with 87%. So 100%, which is all of them, minus 87% leaves us with 13%. But notice I keep saying percent. All we have to do now to find the probability that your first groupmate has 2 or more semesters of calculus is simply take 13%, move the decimal 2 places to the left, and your answer is 0.13. So, the next question, what's the probability the first groupmate you meet has studied some calculus? Well, some calculus means they might have taken 1 semester, or they might have taken 2 semesters. So when we look at it that way, I'm inserting the word or here. And we've already learned that the word or means add. Well, what was the probability that they took 1 semester? Well, if we go back and we look at the blue here, 32% have taken only 1 semester. So 32% would be 0.32. Or means add. Those who have taken 2 or more semesters, we just found that number in part A, so that's 0.13, for a probability of 0.45. So again, or means add. What's the probability that the first person you meet has studied no more than 1 semester of calculus? Another phrase, no more than 1. No more than means whatever the quantity, which is 1, or less. Well, the only thing less than 1 is 1 or none in this case. So we already know that 32% have taken 1 semester, so that's 0.32. Or means add. And the students who have taken no calculus is 55%. So 0.55, and that is where we get an answer of 0.87. Or means add. Just focus on what are they asking you to add. Okay, so let's look at the next set of examples. You are assigned to be part of a group of 3 students from the Intro Stats class described in example 10. What is the probability that of your other 2 group mates, so now we're focused on 2 people, neither has studied calculus? So that means person number 1 has had no calc, and person number 2 has had no calc. Well, if we refer back to our previous example, no calculus was 55%. So the first person having no calculus is 0.55, and means multiply. The second person having no calculus is also 0.55. And so if you multiply those in your calculator, you get 0.3025, and we leave it just like that. What's the probability that both have studied at least one semester of calculus? Well, at least one semester was that some calculus that we did on the previous example, part B. We learned that some calculus was 0.45. So we want the first person to have at least one semester and the second person to have at least one semester. Okay, that at least means one or more. So the probability that the first person has one or more semesters is 0.45, and multiply. And the second person has at least one semester is also 0.45. We put that in the calculator, we multiply, and we get 0.2025. So far, hopefully these don't seem too difficult. So let's look at one tricky question. We want to know what's the probability that at least one person has had more than one semester of calculus. Anytime you hear the phrase at least one person, that's tricky because it could be that your first partner has had more than one semester of calculus. It could be that your second person has had more than one semester of calculus. It could also be that both of them have had more than one semester of calculus. And those are a lot of different cases that make it very difficult to go through. So instead of at least one, we use that complement that we talked about last lesson. The complement of at least one person having more than one semester of calculus is that no one has taken more than one semester. So this one is much easier to find. The probability that person number one has had no more than one semester, which by the way, we're referring back to example 10. We just found out, example 10C, that no more than one semester is 0.87. So the probability that the first person did not have more than one semester is 0.87. And multiply, this probability that the other person has had no more than one semester is also 0.87, which is 0.7569. Well, we are using the complement right now. So if you're using the complement, if you remember from the last lesson, to find the answer we want, you need to take 1 minus the answer that you just got. That comes out to be 0.2431. That is the probability that at least one of your group mates has had more than one semester of calculus. All right, so let's look at the next set of examples. So a Pew Research poll in 2007 asked 2,020 U.S. adults whether fathers today were doing as good of a job fathering as fathers of 20 to 30 years ago. Here's our other responses. So we know 424 people said they are doing better, 566 are doing the same, 950 are doing worse, and 80 had no opinion. And that totals your 2020. So we are selecting a respondent at random from this group of adults. We simply want to answer the question, what is the probability that the selected person responded worse? Well, worse is the 950. Out of, we always have to have a total, the total number of people surveyed is 2020. Well, we can definitely reduce both of these because if you notice, since they both end in zeros, we can divide them both by 10. That reduces to 95 out of 202. And that's your answer. Part B. What is the probability that the person responded the same or better. So the same would be the 566 out of 2020. Or means add. Better is 424 out of 2020. So when we add those together, because they are common denominators, we get 990 out of 2020. Well, we got to reduce. Again, they both end in zeros. Divide them both by 10, we get 99 out of 202. And that's the end of that example. That one was meant to be a little easier. Let's look at example 13. Example 13 has several parts. We have 3 to go through here, and then 3 more to go through on the next slide. So the American Red Cross says that about 45% of the U.S. population has type O blood, 40% type A, 11% type B, and the rest type AB. Someone volunteers to give blood. What is the probability that this donor has type AB? Well, this is the rest that we were talking about. So we need to figure out what percentage is left. Well, 45% plus 40% plus 11% is 96%. Take 100 minus that 96%. We're left with 4%. But we need that in decimal form. Divide it by 100 or move your decimal and you get 0.04. Has type A or type B? Well, type A number was 40, so 0.40, or means add. Type B was 11%, or 0.11, for an answer of 0.51. That one's done. What is the probability that the person is not type O? When you hear not, complement is always a very easy tool to use. So all we simply want to do is take out the O people. So I'm going to take 100. I'm going to subtract the O people, which was 45%. That leaves me with 55%, which is 0.55. And so those were easy numbers to find. Now we're going to build on this example. So let's look at the next slide. Now, we now have 4 potential donors. So we're looking at 4 people now. What is the probability that all of them are type O? Well, type O was 45%. So the first person being type O is 0.45. The second person being type O is 0.45. The third person being type O is 0.45, as is the fourth person. The question is, what word is connecting there? Well, we want all 4 of them to be type O. So that means that we are saying the first one is type O, and the second one, and the third one, and the fourth one. So as you can see, that is multiplication. Now, when we multiply this time, for the first time, we're going to get a longer answer. My general rule with decimals on problems like these, I want 4 decimal places. So we're going to round that to 0.0410. 4 decimal places if you're doing a percent problem. So what's the probability that no one is type AB? Well, the rest were the ABs back on that previous slide. So there was only 4% that were AB. So everybody else was 96%. So no one type AB. Well, that means the first person is not type AB, which is 0.96. And the second person is not type AB, 0.96. And the third person is not AB, 0.96. And the fourth person is not, 0.96. Multiply all of those, round to 4 decimals, you get 0.8493. So, this is where we get a little trickier. They are not all type A. This is where we have to understand the word. When we say they are not all type A, that means that we could have 1 type A, no type A, 2 type A, 3 type A. The only thing we can't have is all 4 of them as type A? Well, that's the key. Because not all 4 of them are type A, we're going to use the complement because there's way less cases if we use the complement. So the complement would be all of them are type A. Well, that's easy to find. The type A people, if you look back at your numbers from example 13, was 40%. So the first person is 40, and the second person is 40, and the third person is 40, and the fourth person is 40. Well, that comes out to be 0.0256. But that's not the answer we want, because that was all 4 of them type A. We want the complement. So we're simply going to take 1 minus that 0.0256, and the answer that we want is 0.9744. Last one on this slide. At least one person is type B. This is very similar to C. At least one person could be 1 person, 2 people, 3 people, or 4 people. Again, it's just so many cases that it's not easy to calculate. So we're going to use the complement. The complement of at least 1 is that none are type B. Well, type B was, if we look back on example 13, 11%. So if that's type B, then not type B would be everybody else. So 100 minus 11% leaves you with 89%. So the probability that the first person is not B is 0.89, and the second person not B is also 0.89, and the third person not B is 0.89, and the fourth person not B is 0.89, for a total of 0.6274. Well, again, we used a complement, so we're going to take 1 minus that answer to find out the answer we want, which is 0.3726. All right, let's look at our last slide of questions. A slot machine has 3 wheels that spin independently. Each has 10 equally likely symbols. There's 4 bars, 3 lemons, 2 cherries, and a bell. If you play, what is the probability that you get 3 lemons? Well, there's, on the first wheel, 3 lemons out of 10. And on the second wheel, there's 3 lemons out of 10. And on the third wheel, there's 3 lemons out of 10. Notice I said and every time. All we have to do, since those are already reduced, is multiply. 3 times 3 times 3 is 9. 10 times 10 times 10 is 1,000. Well, what's the probability we get no fruit symbols? So we want only the bars and the bells. So there's 4 bars plus 1 bell, which makes 5 non-fruit symbols. So the first wheel would be 5 out of 10. Second wheel would be 5 out of 10. Third wheel would be 5 out of 10. Well, I'm going to be smart and reduce ahead of time. I know that 5 goes into 10 2 times on each one of these. So there's 2's left on the bottom and 1's left on the top. So that gives me an answer of 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8, already reduced. What's the probability that you get 3 bells? That's considered the jackpot. Well, how many bells are on each wheel? Only 1. So it's 1 out of 10 on the first wheel, and 1 out of 10 on the second wheel, and 1 out of 10 on the third wheel, which would be 1 out of 10 times 10 times 10 is 1,000. Well, what's the probability that we get no bells? Well, if there's only 1 bell on each wheel, then there are 9 symbols on each wheel that are not bells. So no bells. No bells on the first one, 9 out of 10. No bells on the second one, 9 out of 10. No bells on the third one, 9 out of 10. These are already reduced. Multiply, we get 729 on top and 1,000 on the bottom. All right, let's look at our last question. What's the probability that you get at least 1 bar? Well, this is an automatic loser. anytime we see the phrase at least one, we always think, let's do the complement. And the complement would be no bars. So how many bars are there on each one? 4, which means 6 are not bars. So 6 out of 10 times 6 out of 10 times 6 out of 10. We're going to do some reducing. 2 can go into all of those. That reduces to 3 out of 5, 3 out of 5, 3 out of 5. So we have 9 out of, wait a minute, no. Ooh, Miss Simon can't multiply today. 3 times 3 times 3 is 27. Out of 5 times 5 times 5 is 125. But we used a complement. So we need to take 1 minus 27 out of 125. Use your calculator, subtract, put it back into a fraction, math, enter. You're left with 98 out of 125. And that's the end of this lesson.